Welcome to the short preview of next week's IEST online education course, Shock Closed Loop Control. I'm Jennifer Scalina, Communications Associate at IEST, and I'll be the host for today's session. In just a few minutes, I'll hand over the reins to our instructor, Fred Fay. Thank you for joining us all today. This is the fifth in a webinar series covering 6 essential topics in vibration testing. The program schedule is shown here and can also be found on our website at www.iest.org. Course registrations are available individually for each of the remaining sessions. Because this is only a short preview, we ask that you please reserve your questions for next week's full presentation. However, you may also address your questions directly to Fred Fay via email after the session. His email address will be provided at the end. IEST also offers classroom training on vibration testing through IEST's campus training series. Please check our website frequently to see when the next session will be scheduled. And custom training is also available. Now I'm pleased to introduce the instructor for today's preview course on Shock Closed Loop Control, Fred Fay, a member of IEST's senior faculty. Fred has worked in the area of noise and vibration applications for 30 years, including analog and digital control of vibration shaker test systems. He is president of Vibroacoustics Technologies Incorporated of St. Charles, Illinois, which supplies and supports turnkey vibration test systems. Fred is a senior member and a past president of IEST and president of the Chicago chapter. And now, here's your instructor, Fred Fay.
Okay, good morning. And I come to you from almost spring-like conditions here in Chicago. I can't believe it's almost the middle of February, and we haven't had any winter. Not complaining. I kind of like not shoveling my driveway, but anyway, today is the preview for Shock Closed Loop Control. Next week, same time, Tuesday, we'll have the full session. And I like to always remind everybody that the testing that we're doing now, or the testing that we're covering in these short sessions, is all under the heading of environmental testing. So there's we're over in the left side, the vibration test and electrodynamic exciters or servohydraulic exciters. The shock, as was random and signed before, is covered in our vibration controller selection RP. And here's a list of these, of all of our, most of our RPs that are available for your support. So when we look at a system very similar to what we discussed in sign and random, shock is also in the same way done under closed loop, where you select some type of shock profile and send it to the send its drive file to an amplifier, which does its job and amplifies the signal, usually through some switching amplifier, into the shaker, and then having an accelerometer or accelerometers feeding back the signal to the controller. I noticed that I have random vibration controller, but it's a vibration controller that today for our purposes is shock. And then we adjust that profile on the basis of the dynamics and the response of the fixturing and the product that's under test, our UUT, and we adjust these drive profiles, which we'll look at in a few seconds. There's many types of shock pulses. There's classical shock pulses, and why we refer to it as classical is because they're the pulses that were done without computers and back in the day, and I'll show some samples of how that's done. But these are shock profiles that were given to us by our forefathers, and they're the very common shock pulses that are done, and they all relate to a certain types of testing that one wants to do. There's also another type of shock pulse, and that's not a classical, it's a transient. And that's where you take a transient and you record the transient shock pulse from the field, or you may have a drive file from previous tests. And then basically it inputs its time history into the controller and does the frequency transformation, the FFT, and then continuously runs the shock pulse out the controller as I showed in the diagram previously. So if you want to look at shock testing, there's many types of standards, MIL standard 810G being one of them, but there's transportation, packaging, all sorts of organizations that you really just have to Google shock pulse applications or the type if you want it for transportation or packaging. And then you pick either the half sign or the trapezoidal or the rectangular or transient. So this is a table that kind of gives you some guidelines of what type of shock pulse you should use for what type of application. So we can also look at what are some ways to actually produce these pulses. So our forefathers in half sign used a spring, a rubber pad, a sand, and I'll show you a diagram of what that looks like. And then also now, you know, over the last 20 years, being able to do these pulses using a closed-loop controller on an electrodynamic shaker has turned out to be very advantageous because we can repeat it, you know, to almost less than 5%, you know, off accuracy. So you can see terminal peak tooth. You can drop your product onto lead pellets. You can use the ED shaker. In trapezoid, you can do this pneumatically or with a honeycomb, where you absorb more of the energy and control that shape a little bit more. And then transient in pyrotechnics and impact. And all of these pulses now, over the last 20 years, can be programmed into the controller. And if you look, when you pick a type of pulse, you basically adjust it by different controls. The pulse width, how you tailor its tailoring, how you enter the shock pulse, and how you exit it. So there's a lot of technology that goes into just using these shock pulses and then shaping them properly. I always like to include the SRS, the shock response spectrum, in shock courses, mainly because a lot of the testing, when you want to test in for a product to predict what its shock response is going to be, you can use SRS, and it's a different closed loop system, and it's intended as a design tool. And the arrows, you can go from time to frequency, but if you have frequency, you can't come back to time. And that's primarily because there's wavelets for each frequency, and so you can convert these to frequency, but you can't convert the frequency back into the time wavelets. So SRS is not a use for the FFT response. The shock tests are kind of unique. Many of you are probably part of the course on sensor selection and use. Shock testing uses kind of an older style accelerometer to where the electronics are not built into it. So I described two types of sensors back in the sensors session, and voltage type and a charge type. And the charge type don't have the IEPE, the integral electronics, because the shock, depending on how what the amplitude of the shock is, it will damage the integral electronics and the TEDs that's in there. So most of the time, shock sensors are are still just a charge type, and then you need to have a charge amplifier that looks at that. So that's why we have signal conditioning. And then you go into data acquisition and then data reduction. And so that's the instrumentation. And shock measurement in kind of the yesterday mode is, you can see on the left-hand side, if you wanted to achieve a certain shape, you would adjust the type of material that's down under that platen. So then your DUT would be released, and then it would hit the material that's down there, achieving the shock pulse that you would have. So yesterday, there was no closed loop control. You basically shaped your pulses, as I said previously, and then you look at the response and make sure the response is good on an oscilloscope, and then produce more of those. So this would be, let's say, an analog type test. Today, we're fortunate enough that we do have a closed loop controller, and basically we can program these pulses and then keep those pulses the way they are. So that kind of concludes our preview. And again, here's some reference books that you can have. Still not shown is my most preferred one that I've not gotten back from my loan, and that's the Shock and Vibration Handbook. It's almost the Bible of shock and vibe testing. So those are some example magazines, Test and Sound and Vibration, and then also the several books that you can look at. So that concludes today's preview. And next week, I will let you know that shock testing is a relatively short session, so we won't be covering the full hour next week. And I would like to know, I put all these videos of sine and random on sent out to you, so you could go select those. So if anybody did not get those videos, then please email me at this f_fey@msn.com. My intention, when we take up this series in a more intermediate fashion next time, or advanced, is usually I have a live system that we can do sine and random and shock on a shaker system, and that's my intent, to get this back to doing relatively live tests, so you can almost simulate hands-on, so you can see how it's programmed, and you can go and step through instead of having static slides. So with that said, I'm going to sign off now, and if you have any questions, go ahead and send it to my email address. You have a great week, and thank you for attending.
All right. Please remember, if you have any questions, you can email Fred directly at the address shown here. I'd like to thank each of you for participating in the course today, and I hope you'll all join us next week for the full hour of continuing education class on this subject. And remember that details are available on our website at www.iest.org. Thank you.